thanks for the introduction. My name is Zuzana, and I work for ESET as a malware researcher. And this talk will actually be about malware, about some APT that we found in the wild, where the bad guys leverage some old school protocol for GSM fingerprinting, which is interesting. So let's have a show of hand. Do you recognize any of these strings? Okay, some of you do. I didn't, maybe because these are some commands that are older than me. But let's just be serious here. So these are actually commands from a so-called Haze command set, or AT commands. And these were developed back in the 80s to control some devices such as GSM modems or mobile phones, for example, to change connection settings or to dial up. And then later, this command set was extended and new commands were added, and they were both vendor-specific and also standardized, so they were able to support more functionality. And actually, in 2018, there was a security research that showed that these AT commands are not only supported by modems and older mobile phones, but also by most of the modern smartphones. And what is worse, that these commands pose a huge security risk. So what these researchers did is that they extracted firmware images from several smartphones, from several Android devices, from several manufacturers, and then they examined these firmware images to extract the various AT commands. Because a lot of them are vendor-specific, so each of these Android smartphones had different set of commands to support some different functionality. And they actually found thousands of different AT commands, and then they were doing some tests where they connected the smartphones to the computer, and they were sending AT commands to the smartphone. And just by sending these AT commands, they were able to bypass Android security settings, to inject some firmware or touch events or exfiltrate some sensitive data. So this was a research from 2018, theoretical, but actually it's not the only people who were looking at these AT commands. Exactly at the same time, in 2018, there was another group of people who were doing research on AT commands, and we actually found these commands being misused by malware that is targeting Windows platform. It's an espionage platform that we called ATTOR, and that's actually what we're going to talk about today. So to have some perspective, this platform is active since at least 2013, and there were a lot of different versions, but what we are looking at today is this version that was released in 2018 with a major code upgrade where the architecture was significantly changed and improved, and the code is now more professional. And actually, this is the version of ATTOR that is still used today. We have seen the latest samples the last year. So this is what we're going to talk about. And that brings me to today's agenda. So of course, I want to talk about this GSM fingerprinting feature, which is done using these AT commands. And also I want to talk about the other interesting functionality that gave this platform its name, and that is the elaborate network communication, which uses a customized store. But before I go into that, I also want to talk about some context. So who ATTOR is looking at, who are the targets, and of course we want to see something about the architecture of the platform so that we are able to better understand the specifics of the later. So let's start with the targets. The first thing we knew about ATTOR's targets is that it is highly targeted. We've seen less than 30 targets, and these included some high-profile users in Eastern Europe. But that's just our telemetry, and that's likely just a part of the picture, so we also wanted to know more about the intended targets of ATTOR. So what we did is that we looked at the functionality and some artifacts in the code, and we were actually able to learn more. So how we did it: first, you need to know something about the platform, and then we look at the artifacts. So ATTOR has the main part, say a dispatcher, which comes both in 32 and 64-bit version. And then there is a series of plugins for both of these versions. And how this whole platform comes to life is that the plugins are first injected into all of the running processes, and then they load all of the dispatchers are injected, and then they load all the plugins. And the plugins themselves then decide in which of the processes they will get activated. For example, the network communication plugins only get activated in processes that already communicate over the internet. Of course, this is to hide the malicious traffic within a regular stream of network traffic. So similarly, the audio recording plugin is only activated in the processes that already communicate using the microphone, such as teleconferencing or VoIP apps. And this is also true for other plugins, but we are only interested about a screen grabbing plugin at the moment. This is the one that takes screenshots of several applications to be able to report on the victim's activities. And again, it only looks at some specific processes by the process name or by the Windows title, and then it only activates in some of the processes. And when we look at which processes it wants to be activated, we know which application it's interested in, and then which targets it's interested in. So when you first look at the list of the targeted applications, it's nothing special, what you'd expect, some mail services, some social networks, and office utilities. But there's more. There are also strings like приглашение дружить or Yandex Pochta, and these actually all refer to popular Russian applications, including the two most popular social networks in Russia, or a VoIP application provided by a Russian telecom operator. So this seems like ATTOR is specifically interested in Russian-speaking users, and indeed, this is confirmed by raw telemetry. Most of the targets of ATTOR were located in Russia. But that's not all. There are also other interesting strings that point to applications like digital signature utilities or VPN applications, secure email, secure browser. So it also seems like ATTOR is specifically interested in privacy-concerned users. And again, this is confirmed by another part of the code. So see the TrueCrypt, ATTOR is taking screenshots of TrueCrypt, but also it tries to contact the TrueCrypt driver if present on the system. And then it sends some IOCTL codes to the driver. So these IOCTLs are actually used for determining the version of the TrueCrypt if installed. And the interesting part here is that these are TrueCrypt specific, they're not standard IOCTL codes. So not only this confirms that ATTOR is interested in privacy-conscious users, but also it shows us something about the skills of the developers, because you first need to be familiar with the TrueCrypt code and to see how it works before you can use this rare technique. So let's just wrap the targets. ATTOR is interested in two main groups of targets. We have seen high-profile users in Eastern Europe, and then individual Russian-speaking privacy-concerned users. Now for the platform itself, so we've already seen that the main part is the dispatcher, but then there are also the other parts, the plugins that are loaded by the dispatcher and then synchronized with each other. Then maybe a side note, there are 4 local shared folders which are used by the components of ATTOR to share information. So some of the plugins create files in these folders and others read from them. So as for the plugins, there is a installer plugin that of course ensures persistence of the whole platform. And then there are others, but the most interesting ones are maybe these espionage plugins, which collect some information from the compromised computer. And this is information that gets stored in the central upload folder. And now you may imagine that this information gets ultimately exfiltrated to a CNC server, but this is not done directly because it's a Tor service. So ATTOR is using a series of other plugins to do so. So there is a file uploader plugin that would regularly check this upload folder, and if there's any new data, then it prepares the data for exfiltration. Then there is a Tor client plugin. This is not the Tor.exe standard process, but it's a customized version because ATTOR uses a specific interface for all of its plugins, but it is based on Tor. And this one makes sure that it resolves the onion domain, and it generates the circuit and then encrypts the data. And then it uses the last plugin, which is a SOX proxy, that would then contact the server directly. And that was just one part of the communication, but also the server wants to reach back to the compromised computer so that it can send some additional code or data or commands. And this is again done using the SOX proxy and TOR plugin. And this time the commands get relayed to another plugin that we named a command dispatcher. And if there is any new tools pushed to the computer, then these get stored in other central upload folders. And these are then monitored by the dispatcher, so if there is an update for a plugin, then the dispatcher can load it. So there is a mechanism how you can have your malware always up to date, and it works this way. So the interesting part here is that the dispatcher never directly communicates with the CNC server. It always goes through the other 4 plugins, and that's the same for these plugins that collect information. So focusing just on the network communication, it's split into 4 different components, and each of them implements a different layer. 2 of the components are running local servers so that the other components can contact these components and relay the communication through them. I also already mentioned that these plugins get only activated in applications where they're able to hide the malicious traffic within a regular stream of network traffic. And also, the server is a TOR onion service protocol, and it uses a customized TOR for anonymity and untraceability. So this was the platform as a whole, but also the interesting part is how the individual plugins are implemented and how they're synchronized with the dispatcher. So when you look at the plugins and you don't have the dispatcher, you're not able to analyze them because there are a lot of references to some mysterious function. And this function is actually implemented in the ATTOR's dispatcher and acts like a proxy for Windows API functions or cryptographic functions and other functions like this. So only if you have access to the dispatcher, you're able to map it with the plugins and to actually give some meaningful names to the commands. And why this is able to work is that, remember, the dispatcher is injected into the processes where the plugins are injected as well. That means they share the same address space. So it's possible that they call each other's function. So for this specific function, this is passed to the plugins on load by the dispatcher, and then subsequently, the plugins always use the functions of the dispatcher to do the basic Windows API functions and crypto functions. And so this is how the load looks like. The plugins are implemented as DLLs with a, I'd say, traditional export name DLL get class object, but this is not the important part. There are 2 other parts. So first, this is where the dispatcher passes the pointer to the helper function or to the dispatcher function to the plugins. And then this is where the plugins return the plugin ID and the plugin version. And this helped us sort all of the plugins that we had and to track which plugins are in which version of the development cycle. So these are all the plugins that we have. You can see the IDs and analyzed versions over here. And now these IDs look like the numbering is continuous, and you can notice that we are probably missing some plugins. And that's not so surprising because, remember, the platform is highly targeted, so likely they're using different sets of plugins for different victims. So we probably don't see all the victims and don't have all the plugins. But also it was difficult to obtain the plugins because they're only present on disk encrypted with strong encryption, so you need access to the dispatcher to be able to decrypt the plugins. So if you don't have them, you cannot analyze them. So that's why we don't have all the plugins. Nevertheless, from all of these plugins, we are only going to talk about this one, the device monitor plugin, which is responsible for GSM fingerprinting, among other functionalities. So 2 notes to this plugin before we dive in. First one is that this plugin is assigned ID 1. That's interesting. It's such a prominent space, so maybe it indicates that this is the most important functionality of ATTOR. But also, the version that we analyzed is number 14, and that's the highest of all the versions that we analyzed. And that could also mean that the developers put some more effort into developing this specific plugin. Let's look at it closer. Let's look at the GSM fingerprinting functionality. So we've already seen these strings. Now let's give them some meaning. So these are commands that are referred from ATTOR when some device is connected to the compromised computer. ATTOR is using this AT command protocol. These are just the commands that are used inside the protocol. So we have this AT command that always denotes a start of communication with the device, AT for attention. Then if the computer wants to use this extended set of extended AT commands, it would use this command. And then there are more interesting commands, such as retrieving model number, device manufacturer, software version, and then the IMEI number, which is a unique identifier of the device, the IMSI number, which is a unique identifier of the device subscriber or the owner of the SIM card, and finally the IMSI SDN number, and that's the mapping between the owner identity and a telephone number. So just to recap, what ATTOR is doing is that when it detects a device connected to the computer, it starts sending AT commands to communicate with the device, and by that, it's able to retrieve information both about the device itself, but also about its subscriber, its identity, and also its telephone number. And you may have noticed that I have used the term device a lot, but I never specified what kind of device ATTOR is after. So that was actually the question that we were asking as well. So what devices is ATTOR trying to fingerprint? Is it the modems? Because originally the AT commands were developed for modems. Or is it some older phones which also have SIM cards and support AT commands? Or is it possible that it targets some more modern devices that also have SIM cards, such as smart cameras, smartwatches, or smartphones? From the research from 2018, we have seen that smartphones also support AT commands, so it would be possible to exfiltrate sensitive data from the smartphones just by using AT commands, and also much more. So that was our first hypothesis. And we checked how ATTOR is actually connecting to the devices. So this is part of the code where ATTOR detects that some device was connected to the computer and decides whether it would send AT commands to the device or not. So what it does is that it checks for the device friendly name, and then it searches for a COM substring in the friendly name. And that means it targets devices that are either connected to a serial port or a virtual serial port. So not your standard smartphones. Normally, when you connect smartphones to your computer, you use the USB port, and then the friendly name looks completely different. So either there's like the smartphone name, or there is a USB substring, but not this COM substring. So it seems like although it would be possible to fingerprint smartphones, ATTOR is completely ignoring them. If there is a device connected to a USB port, it doesn't send the AT commands at all. So then we considered a totally different hypothesis. Maybe this is indeed just that ATTOR is trying to look for some old modems or old phones. The platform has been around since 2013, so it could be some residuum. If we remember that it only targets devices that are either connected to the serial port or by a USB to COM adapter, and also if we remember that GSM modems and some older phones do support AT commands. But this also turned out not to be right because we've seen the plugin used for the first time in the new upgraded version that was released in 2018, so never before. But more importantly, in 2019, we have seen a new upgraded version of this plugin recompiled to 64-bit architecture. So if it was really just a residuum, not used anymore, why would the attackers bother recompiling the plugin for a 64-bit architecture? So we don't really think this is the case. We think that the developers behind ATTOR do know what they're using the plugin for, and they do know why they're keeping it up to date. And so there are different theories and different kind of devices that could be affected by this malware. So first of all, obviously, it's the modems and older phones, which can be both connected by serial ports and support AT commands. But then also, if you consider the types of victims that ATTOR is after, which is also some high-profile users, these can be some governmental organizations, and they can use some specific specialized GSM communication devices, or basically any other devices that satisfy these conditions. The attackers behind ATTOR could have learned about these specific devices using other reconnaissance methods, and we can only guess what types of devices these are. And then there are further possibilities. These are not probably targeted by ATTOR, but there can be any other malware which will take these other devices as targets, such as ICS devices, which do support AT commands and are connected using serial ports. Or, as I mentioned before, it can take smartphones as targets and do the same just by not ignoring the devices that are connected to the USB port. And if this is true, then the implications are huge. So first of all, we've already seen that ATTOR is doing some device fingerprinting, so it queries for the identifiers of the device and the subscriber. So after it has this information, it can do several things. Either it can do geolocation in some certain scenarios with these numbers. If you have also other resources, you're able to locate the connected device. But also in other scenarios, remember there are thousands of other AT commands and they are mostly vendor specific. So if the attacker has this information, they can then craft another plugin which is specifically made using the AT commands that are supported by this specific device, and that can serve as a base for further data theft or device compromise, such as pushing some corrupted firmware or whatever else the attackers have in mind. So to conclude, we have seen three things that I would like to have you as free takeout from today. So first, of course, we were talking about this ATTOR malware, but this is not the most important one. But let me just summarize. The ATTOR malware is targeting two groups of users. It's individual privacy-concerned users that are Russian-speaking, but also it targets high-profile users in Eastern Europe. And we don't know who is behind this malware, but judging from the technical complexity and the unusual functionality, we certainly know that substantial resources must have been invested into development of this malware. So it's worth further tracking. But more importantly, what we have seen today is that even these old-school protocols, such as AT commands, are worth checking and looking into because they still can pose a security threat nowadays, even if you have it supported in by some modern devices. And most importantly, we can see that it's really important to do both theoretical and practical research. So we need to do more research that is also looking at what is currently being used in the wild, but also looking for other possibilities. Because as we can see, the attackers are also doing their own research, and we need to know where they are, and we need to be up to date with what they're up to. So with this, I would like to conclude my presentation. If you would like to read the whole white paper on ATTOR, then you can use this link, and thank you for your attention.